Hello everyone, welcome to another chapter of Graph Theory Visualized. Today we're going to be looking at the degree of a vertex. Why are we interested in such a parameter? Well, for one, it gives us a way to look at the graph at the vertex level, as well as an alternative representation of the graph. We'll see why this is useful later on. As always, some definitions. The degree of a graph can be seen as the number of edges for a given vertex. It's a very simple parameter, as you can see. A vertex with a degree of 1 is known as a leaf, and a vertex without an edge is called an isolated vertex. Why is it called a leaf, you might ask? That's because a graph with leaves and no cycle is called a tree. Mathematicians do touch grass after all. Anyways, back to the topic of graph degrees. I'd like to introduce some notation. The degree of any arbitrary vertex v is noted as deg v. The vertices adjacent to v are called neighbors. Therefore, the number of neighbors is also equal to deg v. In typical math fashion, here comes a bit of Greek. The minimum or smallest degree of a graph is the lowercase delta symbol. The maximum or largest degree of a graph is the uppercase delta symbol. This leads us to the following inequality of the graph, telling us the bounds of a degree of a vertex. It seems pretty obvious. The vertex can have less than 0 neighbors and can have more than n-1 neighbors. Here's an example of this inequality at work. Notice that the sum of degrees is 2 times the size of the graph. Remember that the size of the graph is the number of edges in the graph. This isn't a coincidence actually. It leads us to our first major theorem of graph theory, aptly known as the first theorem of graph theory. The first theorem of graph theory, or FTGT for short, goes as follows. Given a graph G of size m, we get that the sum of vertex degrees is equal to twice the size of the graph. Now the proof is fairly short. Given any graph G, each edge of G is counted twice, once for each of its 2 incident vertices. This is a very useful theorem, as it allows us to solve graph problems without even having to draw the graph. It allows us to use old-fashioned algebra. For example, we can solve the number of vertices with the given possible degrees of a graph. There are many more theorems and corollaries built off of the first theorem of graph theory, but for now, this is just an introduction. In the next chapter, we will be exploring an interesting class of graph where we constrain the minimum and maximum degrees of a graph. These are known as R-regular graphs. I hope you learned something new in this chapter. Until next time.